Let's take a look at a few other examples of simplifying radicals. In the first one, we are given the square root of 2/3. We're going to break this up, and we rewrite it as the square root of 2 divided by the square root of 3. Well, one of the rules for a radical expression being in simplest form is that there's no radical left in the denominator, and that's not the case here. So we need to do a little trick in order to get rid or remove the radical from the denominator. Okay, so what we'll do is multiply by whatever the denominator is. So the square root of 3 divided by the square root of 3. And that is fine to do because we're not actually changing the value of the expression. We are just multiplying by a modified version of 1. And now we can multiply and simplify. So we multiply the numerators together. The square root of 2 times the square root of 3 is the square root of 6. And then when you multiply the denominators together, you're really just squaring the square root of 3, which is 3. And we ensure that there are no other perfect square factors under the radical, which there are not, and there's no other factors that we can cancel. And this is our final answer. For the next example, we're going to simplify the square root of 54xy squared over xz cubed. And before I get started, I always like to look and see if there's any common factors that we can cancel out under the radical. And it looks like there are, so I'm just going to cancel out the x's, and now we rewrite the expression as the square root of 54 y squared over z cubed. And we're going to break this up so we get the square root of 54y squared over the square root of z cubed, and then just try to simplify the numerator and then the denominator. And the square root of 54, well, 54, I'll do a little bit of scratch work, is 9 times 6, and that gives me a perfect square factor of 9, so we're going to bring out a 3, the square root of 9. So 3, and then square root of 6. But the square root of y squared is just y. So we have altogether 3y square root of 6 over, and the same thing, I'm going to go ahead and simplify the square root of z cubed, and that is z times the square root of z. But just like the last example, we don't want any radicals in the denominator. So to eliminate the square root of z from the denominator, let's multiply by the square root of z over itself. And we're left with 3y, and then square root of 6 times square root of z. Let's combine those radicals and we get square root of 6z in the numerator divided by z times, altogether square root of z times itself is just another z. So we have z times z, or z squared, in the denominator. In the last example, we're trying to simplify 81 to the 3/4, and using the property of rational exponents, which says we can rewrite this as, so x to the a over b is the same thing as the bth root of x to the a. And that a can go in a couple of places. It can go under the radical or outside of it. So in this case, 81, that is the radicand. The 4 is going to be the index, so we all together have the 4th root of 81. And then we are going to cube that, and that comes from the numerator. Okay, well, the 4th root of 81, because 3 to the 4th is 81, the 4th root of 81 is just 3. And then bring down the cube, so 3 cubed is 27.